The things that you're going to learn as we progress, you're going to understand why selecting the right instance type for your managed node is important. Hey everybody, hope you guys are doing well. In this video, I'm going to talk about how you can set up your EKS cluster using AWS Console. There are other ways you can set up your cluster like EKS kernel, AWS CLI, or even Terraform. But in this video, I'm only going to focus on using AWS Console. So we will create EKS cluster and the VPCs that's gonna just the VPC and the subnets that's gonna need. After creating cluster and the VPC where the cluster is gonna live, we will configure our laptop to talk to our cluster over the internet, and then we're gonna configure worker nodes using Fargate. And after using Fargate, we're gonna configure our worker nodes using managed nodes. And then we will combine two solutions, Fargate and managed nodes. And after that, we're going to compare the Fargate versus managed nodes. And the things that you're going to learn as we progress, you're going to understand why selecting the right instance type for your managed node is important, and what to expect when you set up Fargate, and what happens to the node parts that are in pending state. So those are the things going to happen as we do the demo, but some of the mistakes I'm gonna make it deliberately, so we'll understand why things work the way they work. So the first thing we're gonna do, we're gonna create the VPC. VPC is gonna have two private subnets, two public subnets, one NAT gateway, so that the private subnet could communicate with internet. That is something that's going to be needed for our cluster. So if you're going to create pods in a cluster, you may need to pull images from Docker repository or other sources. So we're going to make sure we have a NAT gateway in place. So let's create the VPC. Sorry, I was on the wrong screen, so I'm going to go to the VPC now. So when it comes to configuring CIDRs, you can leave the default values. I just like to configure it. I just like to have a control and scope the subnets based on my needs. So, but if you want to leave it, the values, whatever's prompting up on the screen, you could do that. So now let's create that one. So when it comes to creating VPC, most of the components get created relatively quick. The only component that's take a minute or so is NAT gateway. So we're gonna wait on that and let that to finish, and then we'll continue. Okay, so our VPC has been created. The NAT gateway creation did take more than a minute, so it could take longer. Just be mindful. So now we're going to view our VPC, and the one thing we're going to review before we create a cluster is the security group. It's a good idea to take a look at it, what kind of rules that are prompted by default. When it comes to inbound rules, the traffic is limited within the VPC, and that's what we wanted. And for the outbound rules, the traffic to internet is allowed. When you're going to configure your cluster for different services and going to expose using a node pod or something like that, you may need to configure your security group. So for this setup that we'll be doing, we're not going to do that. We're not going to create the services or any sort of a Kubernetes object. We're just configuring and setting up the cluster. So I'm going to leave the rules as it is. So the VPC is created. So now let's create our cluster. So there is a quick configuration mode available. So it would ask you to select that. Auto mode is relatively a new offering from AWS. I'm not going to go with that. Maybe I'll make another video explaining that. But for today's video, I'm going to select custom configuration and make sure that we don't use EKS auto mode. So disable that. Give a cluster name. I'm going to name it EKS demo. When it comes to roles, so the roles gonna be required for cluster to make changes to configure your cluster properly. So if you don't already have a role created, you can create the recommended role, and it will auto select some of the policies that are required. It'll select the service that it's gonna use, and it'll attach the single policy, EKS cluster policy that is needed. It may or may not be enough. We'll find out shortly. So naming the role. So now we're going to go back to where we're creating the cluster, and I'll select that role, and you'd notice that it's telling me that the role is missing some policies. So we got to make sure that particular role has those policies attached. So we're going to do that. So even the recommended role that we created off the portal sometime may not attach the policies that the cluster needs. So let's attach those policies real quick. So when it comes to policies that we attach, so it's going to have limited access to different resources. For Amazon EKS block storage, it's giving access to attach volumes or modify volumes. And similarly, the cluster policy rule, the policy is allowing you to create EC2 instances or even modify them. So this is something cluster is going to need. So this role required those policies. So we just attached them and they've been saved. So if we go back to the cluster now and refresh it, it's not going to complain that the role is missing any policies. Okay, so now when it comes to picking a version, you can pick the latest one. The latest one is actually 1.32. It just came out not long ago, but on the console or AWS, you still have 1.31 to select from. When it comes to upgrade policy, it's applicable that if you want to have extended support for your cluster, but for this setup, I'm gonna go with the standard one. I'm not gonna be upgrading my cluster for this demo, so we're just gonna leave the standard. And for the auto mode compute, we already disabled it. And then comes the cluster access. How do you want to access your clusters using EKS API or config map? So you could just select the EKS API. It's kind of like pretty standard. That's how a lot of people do it. If you want to disallow cluster administration access altogether, you can even opt for that, but I don't see a reason why would you do that. So you're creating a cluster, you definitely want to have administrative access to it. When it comes to secret encryption, so you could even encrypt the secrets that are going to be created on the cluster, and you would have to create KMS key for that. I do not have KMS key created, so I'm gonna keep it disabled since we're not creating any objects. So I'm not gonna bother with enabling encryption, but if you need to encrypt your secrets using KMS key, I would recommend you to kind of turn this on. When it comes to ARS zonal shift, this is something that AWS offers you in case their particular availability zone goes down. It would route the traffic to a healthy zone and it would prioritize the traffic for you. So I don't need this offering, but if you do in your environment, you may consider enabling it. But if you're just learning it and practicing how cluster setup works and everything like that, I would recommend you to kind of leave it disabled. And then we're going to go to the next. So now we're going to configure the networking. When it comes to networking, we're going to select the VPC that we created before, and we're going to select all the subnets. And the security group, we're going to go with the default that got created with the VPC that we created before. Select that. So we can configure the IP block for our services. In this case, again, I'm not creating any object, so I'm gonna leave it as it is. And we can also, if you're gonna end up creating hybrid nodes for your managed nodes or for your Fargate or nodes, adding nodes from your on-prem service, like on-prem environment, then you may wanna specify that CIDR here. So next, we have cluster endpoint access. So how do you want to access your cluster? So if you select private, that means that the only people who have access to the VPC or within the VPC are using a VPN or the nodes is created within that VPC. Those are the only people who will be able to access it. And the worker nodes that we're going to create, of course, they will be within the VPC as well. So if you select public, that means that all the worker nodes, all sort of objects that we'll be creating, even the access into the cluster, everything will happen over the internet. So they'll be routed through the different endpoints and then reach the cluster over the internet. So they'll be considered kind of outside of the VPC, but I'm gonna configure public and private with this. You can access your cluster endpoint outside your VPC. That means you can I can access cluster from my laptop on a different network, but the worker nodes that are gonna be created, they will stay within the VPC. So that connection will be private. So after I'm gonna select public and private and click next. So when it comes to observability options, we're not gonna focus on that in this video. So I'm gonna leave everything unselected and click next. So now there are add-ons. So some of the add-ons are required for hybrid setup or when we're going to use the managed nodes. So kube-proxy is essentially, it's used for routing between pods and services. It's used in the load balancing to balance traffic between different pods that are behind your service. When it comes to core DNS, it's required. It kind of provides you DNS-based services for your cluster object. It maps the service names to their respective IPs. So, and then you have Amazon VPC CNI. So this is a networking plugin that you're gonna need to have when you're gonna create managed nodes. This isn't required for Fargate, but it's definitely required for managed nodes. So what it does that it allocates the IPs from your VPC subnet ranges so that the pods can communicate with communicate with other pods. So basically the network plugin is required for pods communication. This isn't required for Fargate. Fargate take cares for us. Everything happens behind the scene. AWS manages for us. Fargate also assigns the IP addresses from the VPC subnets, but it does everything behind the scene without using some sort of a plugin. So when it comes to node monitoring agent, it's required for health issues. We could essentially disable it. We're not gonna need it. I'm only gonna select 3 that we need to: kube-proxy, core DNS, and VPC CNI. So these are the ones we'll be utilizing. Kube-proxy, not so much. Core DNS and VPC CNI are definitely required, and I would definitely recommend you to turn those on. If you require any additional add-ons, you can select from, and there are also add-ons available from the marketplace. So whatever you need, whatever the additional configuration you need to have it on your cluster, you can definitely find it on the marketplace. If not, you could use Helm, other tools to configure it from the different sources. So after configuring the add-ons, I'm gonna click next here. And it's just an overview and telling us that what sort of a version we want to use for our add-ons. So I'm going to leave whatever's selected default and click next. And this is just a review page and it's telling us what are the settings we have selected for our cluster, and then click create. So once you hit create, creating a cluster takes about 10 minutes. So be patient on this one. I'm gonna pause the video for now and come back after 10 minutes once the cluster has been created. Okay, so our cluster has been created. It took about 10 minutes as I expected. So now our cluster has been created. Now we're gonna configure my laptop, my terminal, to communicate with this cluster and see what's happening on this cluster. So let's get to my terminal and I will configure my kubectl configuration. Run AWS EKS. So the context for my newly created cluster has been added to my client machine. If you don't have kubectl set up and you don't have kube directory set it up, check out my other video. I'll leave the link below in the description where I covered how you can set up kubectl on your client or on your laptop to communicate with the clusters. So we added the new new context, so I'll just check out if it's the current context. So I'll run kubectl config current context, and yeah, so this is my current context. So if I run kubectl get part, so I have nothing running there. So I should have parts running in other namespaces though. So let's see. I have nothing, so let's see what else I would have. Get namespace, anything like that. Okay, so I do have 3 different namespaces. So if I should get some sort of parts that may or may not be working. So let's see what's in the kube system. Okay, so I have no parts, so that's somewhat strange. So if I have add-on, something like core DNS, it should try to create some parts. Oh yeah, because it's still in the creating state. So we'll wait here for a couple of minutes until the add-ons are added, and then I should see that the core DNS parts are trying to be created. So, and they won't get created, they'll stay in the pending state. Yeah, they'll stay in the pending state, but we will see, at least we will see them that they are there and the cluster is trying to create them. So talking about some of the things about EKS cluster, that EKS cluster is essentially, or EKS is a service, so not a node that we can interact with or we could kind of configure our parts. So it's only created a control plane. We can schedule our parts on it. AWS manages this for us. It does the updates on the node and it takes care of whatever it needs to do. If we need to upgrade it, we'll have to do it. AWS is not going to upgrade our Kubernetes version for us. But if we try to create any parts, any resources now, since we don't have any worker nodes available, those parts will stay in the pending state. So even though we're waiting on the core DNS parts, I'll try to create a new part. I'll just name it Nginx and provide the image name. So this is going to create an Nginx pod in my default namespace. So if I do kubectl get parts, it'll stay in the pending state. If I try to describe it, so it'll tell me that there are no nodes available to schedule my parts. It's obvious that we can't schedule our parts on control plane, so we have to create worker nodes. So let's see if the core DNS parts are trying to be created on our worker node. So let me see. So the add-ons are still being added. So we'll wait here for a few minutes, and once they are created, I'll continue the video. I'm just going to pause it here for the minute. Okay, so looks like our add-ons been created. So if I go to the resources tab, I'll see that there are parts that core DNS add-ons trying to add. So now if I go to my cluster and trying to get parts from all namespaces, I should see core DNS parts. So as I expected, they just trying to be created a couple of minutes ago, and they're in the pending state. So I expect to have a similar message as we saw for Nginx, that there are no nodes available. So if I do kubectl describe pod, yeah, so it's seeing the same error message saying that there are no nodes available. So So now let's create worker nodes for us. So first we're gonna use Fargate method, and then we're gonna go with the manage node. So let's go to our control plane and switch it to compute tab, and come down and click on Fargate profile. Name your profile. I'm just gonna name it EKS cluster profile. And it expects to have some sort of a role created for execution. So just go to the recommended role, click next. It's gonna auto assign a policy that is required, and just name it. So I just created the role. Now it's available for me to select from. And when you're creating a Fargate profile, it's going to create your worker nodes in a private subnet. So you have to select private subnets. So here within this VPC, I only have 2 private subnets, and that's what is selected. And then click next. So this is the relatively important step. So you're telling what sort of parts you wanted to select for Fargate, and some sort of a parts that you want to have it scheduled using Fargates. So you could define the namespace. You could type in default or kube-system. So let's just type kube-system, and you could also further kind of modify your selection and select particular type of parts, and that'll just, this is kind of like a suggested approach, so that you only schedule parts for different type of only schedule parts that are required to be scheduled. So you could even define the labels that you have it on your parts, but for in this case I'm just gonna define it the namespace. If you need to add additional namespace, you can just click on the add namespace. I'm just gonna do the kube-system namespace for now. If you would have noticed that our parts that are being created core DNS, they are in kube-system namespace. So I wanna have those parts scheduled. So with the profile that I'm creating, the nodes that are in default namespace, they won't get scheduled. So this is the beauty of the Fargate selection. So it works based on the selection, then it creates the nodes for us. So click next, and then just kind of create the profile. One thing you would notice, this is relatively quick. It may take about a minute or so. Okay, so our Fargate profile has been created. So if I go back to my compute, I don't see any nodes created, and I defined the namespace. If I go to my cluster and get parts, they are still in pending states. They are not being scheduled. So the reason being is that when you use Fargate profile, Kubernetes doesn't retroactively match the parts that already exist in this environment. So the Fargate profile is only applicable for newly created parts whenever the Kubernetes is trying to create it. So whatever you already have in a pending state, it's not gonna get matched with the Fargate profile. So for us to match the core DNS parts with Fargate profile, and then so that they get scheduled to worker nodes, we'd have to kind of restart our deployments. So these core DNS are being created from a deployment called, I believe, core DNS. Let's just try to get its name. So yeah, so this is the deployment that is deploying this part. So what we're going to do, we're going to restart this deployment so that kubectl or Kubernetes is trying to recreate them, and in that process the Fargate profile is going to try to match the namespace and whatever the label it has, and create the nodes accordingly. So let's do that. So as soon as I do that, I restarted it. I'm gonna get my parts. So they're still in pending state. But if I go to my cluster, Fargate's gonna try to create nodes. So it has matched it. It's gonna match the label that is gonna say that, oh, these parts are in kube-system namespace. Let's try to create and schedule those parts. So within about 30 to 60 seconds, Fargate's gonna create a node and it'll schedule the pod for us. It takes about 30 to 60 seconds. So we're gonna wait for 30 seconds here. Okay, so Fargate has created the node for us. You will be able to see it under compute, under nodes, and you see that the Fargate has created this node for us. If I go back to my cluster now and get the status of those pods, they are in running state now. But in Nginx, which is in the default namespace, it's still sitting there, still sitting in a pending state. If I want to have that pod also scheduled, I have to do the same process. I have to go back to compute. I could create another app profile, and in this time I could just say EKS cluster profile 2, using the same role within the same subnets, and this time I'm gonna have default namespace created. And again, it's gonna same thing's gonna happen happened before. It's not gonna create the resource for me, and it create the instance for me and schedule the pods. Good thing that I'm on the screen, and I also want to point out one thing, that the Fargate determines on its own how many nodes it needs to create. You wouldn't have a control on the number of nodes it's going to create. For our previous namespace, the previously when I created a profile, it created 3 nodes for us, and it's possible that there are additional, actually created 3 and it's downsized to 2. So it creates the number of nodes on whatever thing is appropriate number. So you don't really have a control on it, how many nodes it's going to create to schedule your pods. So we just created another profile for default namespace, and same thing's going to happen, that our pod's not going to get scheduled. If I want to have it to be in running state, I have to restart it, or maybe kill this pod and recreate it. Okay, so the image name is incorrect, so let's quickly correct that, but it should still trying to schedule my pod, so this should error out. So let me just quickly rename it and then delete the one that I don't need. So now if I try to get my pods, it should try to schedule on some sort of a node by Fargate. So it takes about 30 seconds. You would notice that the Fargate's gonna create a new node here for us based on whatever the load we're providing it to. So you should shortly see within 30 seconds that the new node is created, and that where our newly created pod in default namespace gonna get scheduled to. So still in the creating state. Okay, it's running now. That means that there's got to be a new node created. So let's quickly take a look. And yeah, Fargate did create a new node for us. So it's all happening based on the selection based on namespace. So you could also describe it further, what sort of parts you want to select it. So let's explore what happens when you create a Fargate profile. And I'll explain it. And let's just quickly do this first. So I'll delete the second profile. Okay, so when it comes to deleting Fargate profile, it does take relatively longer. You notice that while the profile has been deleted actually, it's also deleting the nodes that it created. So it just deleted the node that the profile created. And if I go to my cluster, my pod is also deleted. So that's how it works. When you delete any Fargate profile, it's gonna delete the worker nodes that it created and any sort of pods that are scheduled on it. So if they're not part of the deployment, they're not gonna be Kubernetes is not gonna try to recreate it. So if they were created, the pods were just created, just a single pod, and they're gonna get destroyed and it won't get recreated. But if I delete my another profile, let's say EKS cluster, What happens that it's gonna do the same thing. It's gonna delete the node and delete the parts that are scheduled on it. But there'll be a difference. What's gonna happen this time, because since this parts, the core DNS parts are part of it deployments, Kubernetes is gonna try to recreate them, and they're gonna stay in the pending state and pending status actually, and they'll just be gone. The existing parts would be gone. The new parts would be created off the deployment. So we're just gonna wait here for a minute or so while this nodes get deleted. Again, it takes about a minute or so, so just be patient on this step. So whenever you're working with EKS cluster, most of the things you do, it takes relatively longer. Nothing is kind of instant because serverless solution. It's not like works off the seconds. It still needs a bit of a time to process and create the nodes behind the scene. Okay, so it has deleted the nodes, and if I go back to my cluster and trying to list the pods, they are in a pending state. So you could say off their ages, they are 12-13 seconds ago. So that's what the Kubernetes is trying to create. So they are in a pending state. The standalone pod that we created has been gone. Kubernetes is now going to try to recreate it. And yeah, so that's how the Fargate works, and how the selection works. Like, you got to define the namespace, and if you want to configure pods, particular type of pods, you can even define their labels, and it would create the nodes for you, and those worker nodes where Kubernetes will schedule your pods. Okay, so now let's create managed node groups. So apologies, I noticed that I may have been referring to node groups as managed nodes. It's what I meant by like managed nodes and managed node groups. I think I meant by the same thing. So now we're gonna create our worker nodes using node groups. So it's relatively same process. Relatively simple and almost the same process as setting up the profile, but we have a more control on what type of nodes we want to create. So let's go back to the cluster within the compute. Under node groups, click node group and name your node group. So I'm gonna name it EKS demo node group. It does need to have a role created, so just click on the recommended role and create the role. This one is smart enough. It's gonna pick the 3 policies that it needs, and you just leave it selected, click next and name your role. Okay, so our role's been created, so it should be available for selection. So we're gonna click that, and we're just gonna leave it, not gonna use the launch template, so we're gonna leave it unselected. You could use the labels for Kubernetes, or even what the nodes that particular nodes you want to have it tinted. This is kind of some sort of a configuration you would need it when your application is growing and you don't want to have certain parts to be scheduled on certain nodes. We don't need it for this setup, so I'm just going to leave it as it is and click next. And now it's in our options and type of nodes we want to select. So let's select the cheapest one, and T2 micro, and just select that one. And you're noticing the max IPs is 4. It may not make sense like what it is now, but once the node group has been created and creates the node, we're gonna see why this is important and why selecting a bigger node type is important. But for now, I'm gonna select the smaller type. You could also select another type that the node group will create alongside the T2 micro. But it's just up to you. If you want to do it, AWS is going to give you some sort of a warning that selecting different instance type is not something recommended. So it's always select the same type, and that's how you should scale. So I'm going to keep it T2 micro, and then I'm going to describe the scaling configuration, how many nodes I want to create. So I'm going to select 2. The minimum size is 2. The maximum size is 4. So select set that, and update configuration, I'm just going to leave the number as it is and click next, and it's going to ask you for the subnets it should select from. We should be creating our worker nodes within a private subnet, so I'm going to remove the public ones and only going to select the private one and click next and create the node group. So if I go wait for this to create it, this doesn't take too long. It's going to take about like a minute or so. It's going to create 2 nodes for us as we described in our configuration, that we want to have 2 desired node, and at minimum it's got to have 2 nodes, and the maximum nodes is 4. And we're also going to see why even though some of the parts won't get scheduled, but the size of it won't get increased, and I'll explain that shortly why it doesn't happen. So wait for a minute here for this node group to be created, and whatever the resources it needs to create behind the scene. Okay, so the node group is created, and it created the nodes for us like right off the bat. It's not waiting for any parts to be scheduled, it's creating the nodes right away. So if I go to my cluster and try to see if the part's been scheduled, I already have nodes available, and that's where my parts are being scheduled. You might have remembered the add-ons we selected early on, like a kube proxy and AWS node, some sort of an add-in. So when you're using node groups or managed nodes, you'd have those kind of parts would get created to enhance the functionality of your worker nodes. It's required for whenever you're using node group type of computing for your EKS cluster. So we have additional parts created on our cluster essentially. So one thing I wanted to do, I'll just create maybe a deployment. So I've just created a deployment using Redis image, and it should create 9 parts. So if I do kubectl get parts, all of them are in pending state, only one of them is in running state. So the reason it's happening that if I go back to my cluster, it's gonna have 2 worker nodes, and it's using T2 microtype. If I go back here to its capacity, it could only create 4 parts. So and we have a minimum desired for our nodes to be 2, and the desired number of nodes is also 2. So in total, it could only, this type of instance type could only schedule 8 parts. If I want to schedule more parts, either I have to increase the capacity for my nodes, or I just have to increase the number of my nodes so that those parts could get scheduled. In case you're wondering that why isn't the number of the auto scaling is getting kicked in, like, we selected that, hey, if our load increases, increase the number to 4, like, that's the maximum size limit. The reason is being that the Kubernetes has to have configured some sort of a scaling solution in place. So you could use AWS cluster scaling or even Carpenter for that. So if those are the configure, then only you could scale your nodes. Otherwise, this thing, it's a secondary, like, this thing is definitely required with the node groups, but the Carpenter or the cluster scaling solution has to be in place on cluster to scale nodes if the parts aren't being scheduled. So if you have that, that's only when this configuration is gonna come in handy. And now, so what I will do, you could also create additional node groups just like Fargate. So what I will do, I'll create node group 2, same role, leave the setting as it is, and this time I'm gonna select T2 medium. So this is where the max IP could have is like 3, so 18. So like that means I could have potentially 18 or like 16 Kubernetes objects. So the disk size for this I want to have, and then I'm gonna describe the desired size, the minimum size, and the maximum size. So define that setting and click next. I want to have it in the private subnet, so I'm gonna remove the public subnets and click next and wait for it to be created. So just like before, it's gonna create 2 nodes for us, like how the previous node group did, and it should schedule our parts that are in pending state. So we're gonna wait for a minute or so while the node group is being created. Okay, so now our additional 2 nodes been created, and if I go to my cluster and some of the pods are like, if not, actually no, some all of the pods are in running state now. So what it needed, that it previously it didn't have the capacity to schedule the pods. So what I'm going to do now, we're gonna actually, let's combine these solutions, combine Fargate profile and node group, and see what happens. So what we're going to do, I'm going to create a Fargate profile like we did previously. I'm going to select the subnets, and we're going to use the role that we created previously. Click next. And I'm going to define the namespace. I'm going to say yellow, and click next and create it. So as you would have noted, you know previously that if I have like parts that are running in yellow namespace are in a pending state, they're not gonna get scheduled. Only newly created parts are gonna get scheduled to Fargate. So the reason I'm doing that and combining that to just kind of show you what takes the priority. So what happens that once the Fargate profile is created, we'll just wait here for a minute to be finished. Okay, so our new profile is created. So what I'll do, I will create maybe a new deployment. Oh, I've just noticed that I do not have yellow namespace, so, and I also mistyped the replicas, looks like it. Let's quickly create the namespace. Okay, so now I should have 4 parts created in a yellow namespace, and they should get picked up by Fargate profile, and they won't get scheduled on our node groups but on the Fargate profile. So let's see that in action. So we're just gonna wait here for like about 30 seconds while EKS Fargate's trying to create those nodes for us. So I'm just going to try to get the list of parts that are on yellow namespace, and they are in creating state, or sorry, in the pending state, and one of them is in the creating state. Let's see, it should see another node prompting up from the Fargate. Yeah, that's exactly what's happening here. So what's happening here is that now we have 8 nodes within our cluster, worker nodes. So, and since we defined our Fargate profile and defined the scope and what we want to select and the namespace, it's gonna pick whatever the namespace, the resources we're trying to create in that namespace, and create the nodes for us and schedule our parts there. So the number of the nodes that the Fargate needs, it will determine, you know, based on the load. So you may see that it has created 4 nodes. It may not need 4 nodes. So like we noticed before, it may remove 1 or 2 based on the type of the loads that the parts have. So yeah, that's how you kind of essentially combine it. So like, you know, you could also have Fargate profile and you could have node groups. When it comes to what get prioritized, the Fargate has a bit of a priority over your node group, so it works based on the selection. So that's what get evaluated, and then the node group. So if the profile has some sort of a particular label selection for pods, you know, those would get selected, and the node groups would kind of handle the whatever the remaining. So the only reason you would do that, you may have an application and, you know, you would create particular type of pods or services on certain occasions when the traffic is high, and that's when you would use the Fargate profile so that it could create the resources or the nodes on demand, and use the node groups for the loads that is running all the time, and it's lightweight, and you know what that sort of load is and what to expect from. In that case, you have a more control on of your nodes too, and you just kind of pick the instance types that fits your need. When it comes to comparing them, it's obvious, right? So it's automatic. When it comes to Fargate, with the node group, you'd have to create the node groups. With the Fargate, it does not retroactively looks for the parts that are in a pending state and trying to schedule them, whereas with the node groups, it's gonna try to schedule whatever the nodes that are in a pending state. Kubernetes is gonna see, oh, there's a node available, let's schedule all those parts there. That's the advantage of the node group, and Fargate is strictly selection based, and the node group, you could add taints and stuff like that, but it's just kind of comes in as, again, as a worker node, part of the Kubernetes cluster, and whatever's in the pending state or the parts, they're gonna get scheduled. When it comes to Fargates, you don't have to manage the nodes. With the node groups, you manage your nodes. You can configure them accordingly, and with the managed nodes, you have a more control on or what should node have, and you can also configure the security based on your need. Whereas with the Fargate, you don't really have access to the nodes, and you can't really configure it. You can't even access it. When it comes to debugging and troubleshooting, with the node groups, you're gonna have a direct access to the nodes. With the Fargate, you probably won't. So these are some of the differences on when it comes to node group and Fargate. It's just one is selection based and automatic and serverless. The second solution is more of like you manage it, you create it, and you configure it based on your need. So when it comes to what to pick from, based on your requirements, so whatever's applicable in your environments, you want to have a serverless solution. You don't want to deal with the nodes, and your load is kind of like varies all the time. The Fargate may be a better option, or like you do in node groups and configure the autoscaler and things like that, but within the domain of EKS, the Fargate kind of makes more sense. And the node groups, when your load is kind of like a steady, and that the certain number of nodes could handle that. And with that, that's it with this video. That's all I wanted to cover for this video. I hope you find it informative. If you did, please leave a comment, like, subscribe to the channel. If you want me to cover any particular topics in the future, or particular type of videos you want me to make, do let me know in the comments, and I'll try my best to get back to you or facilitate your request the best manner I could.